Hello everyone, myself I am Saranya, working as an assistant professor in the Department of AIML in MLR Institute of Technology. Today I am going to discuss the topics of digital signature and digital signature standards algorithm. So in this overview we are going to discuss about what is meant by digital signature and what are those key functions and what is digital signature standards. Digital signature is different and digital signature standards is different. So first one is what is meant by digital signature. A digital signature, it is also nothing but one type of cryptographic method. It is basically verifies the authenticity and also the integrity of digital messages, any messages or any documents. So while they are living, before digital signatures, it should be complete a signed document. Then the document owner should modify or he can change the document after the completion of the signature. So that what here saying is document owner could modify or it changes the document after their completion of signature. That is called as a digital signature. So however it will be a digital signature, the whole signature will be an time stamped and the private key is also there. Insertion will be there to the specific document. So while we are creating any documents in our system, so basically we provide a very important password or some type of keys to provide our specific documents. That's why they are providing with for the digital signature, the private key should be inserted to the specific document. So any document changes, your signature will not be longer further, there should not be a valid one. Further, the document will need to be again re-signed procedure. That is called as a digital signature. If the signature will be a timestamp, otherwise the private key is also inserted to the specific document. If there any modification of the changes, your signature will not be valid. So after completion of should not be valid, again we need to re-sign the document. So we can see here the one type of figure which is related to the digital signature. So here there is a type of e-signature that verifies the authenticity of digital document or the message. The whole concept is nothing but a authenticity and integrity. So the both authenticity and integrity only combines to the topic of digital signature. So here for example, here will be then unsigned document, means which is not purpose to the any of the people. So here is an unsigned document. This document is sent to an digital signature software to check the purpose, what it is going to happen inside. The next, the digital signature software is uploaded the any signatures or unsigned documents. It is going to be an signed documents. So it is unsigned. For example, here there is an ABC or DEF GHI. It is an unsigned format. We don't know what it is an inside of that document. So after the process of digital signature software, it is thoroughly moved to the signed document of any signatures which is related to our name or any father's name, any mother's name, that is the valid to the signed document. So here the timestamp will be there with the private key. This should be there by locking any of the software by using the private key with the password or anything. It should be a lock for the digital signature software. That is the whole figure of the digital signature. Then already we have told that previous of the slide digital signature and key functions also. So what is the basic of key functions for this? We can see here. First one is authentication, second one is integrity, and third one is non-repetition. So we basically know what is meant by authentication. So basically the authentication is nothing but an verification of the identity of the sender. So whatever the sender is going to send the messages, he should verify first the message, whether it is ensuring to the document or the any message which is came from them, whether it is true or false. That is called as an authentication. The next one is integrity. Integrity, the content cannot be changed. While they are already it was signed or any information remains, it should not be changed. That is called as an integrity. The next one is non-repetition process. So basically the non-repetition process, it provides basically the proof signer cannot later deny having the signed the document. If for example already the completion of the signed the document, it provides one proof to the signature. Means whoever done the signature, it should be the very clarify for the digital signature process. Then how it works for the digital signature process? First one is key pair, second one is signing, third one is verification, and fourth one is digital certificates. Coming to the key pair, so already we are having the two types of private keys, that is an cryptographic keys. So while we are using the cryptographic keys, we basically uses two types of keys. One is private key and another one is public key. So private key is nothing but only known to the who is going to be signed, that is known the only known person, that is called as signer of the person, that is related to the private key. When completes to public key, which can be shared one, means whole of the outside of the people, they can share the public key, but private key is only user can visible the data. The next one is signing of the process. What will happen in the signing of the process? There should be to encrypt a hash function, means they are uses from private key to encrypt a hash, that is called as an by using unique fingerprint of any document while creating the digital signature process. Means basically, for example, while we are using in our mobiles, we basically keep it as any passwords or face recognitions or any fingerprints based upon the Androids or iOS. That is basically keeps into the fingerprint or thumb or face recognition. Like that, in the digital signature also, they will use an private key to encrypt the hash function by using an unique fingerprint of the document by creating an digital signature. The next one is verification process. So the verification process, it also uses the public key, while the private key is using for the signing of the process and verification is used by the public key process. So signing is to encrypt and verification is to decrypt. After the completion of the decrypt, verify it against of the hash of the received document. So whatever the completion is done here, the encryption is a hash. Then after verification, it is going to be decrypt the whole signature and it verifies again of the whole, whatever happened in the signing of the process, it is going to against of the hash which is received by the from the signer. If the hashes matches, the signature is valid. Otherwise, it should not be a valid. So encrypt is for hash function, decrypt is for verification. Basically, it uses the verification process and hashes uses the signing process. That is the both process we are seeing here, signing and verification. That is the difference. Signing is used for the encryption and verification is used for the decryption process. The next one is digital certificates. So basically the digital certificates is used by the certificate authority. So often by using any to create the digital certificate, we basically trusted by an CA, that is nothing but an certificate authority. So to the public key, to the signer's identity. So basically we are, while you are using the signing of any identity, we need to bind the public key, that is called as an digital certificates. The next one, digital signature standards. So the digital signature is basically, before we have discussed in the previous slide, is it is only useful for the authenticity and the integrity of the whole document or any messages. Then coming to the digital signature standards, it is a FIPS. It is nothing but an Federal Information Processing Standards. So it basically defines which is going to use it to generate digital signatures with the help of SHA. That is nothing but an secure hash algorithms for the authentication purpose. So it is an FIPS, that is nothing but a Federal Information Processing Standards. Basically it defines that algorithm should generate digital signatures with the particular of hash algorithms, secure hash algorithms. Then DSS only provides with the digital signature function, not with any encryption process. So basically in the digital standards, we have digital signature, we have seen the both encryption and the decryption of signing and verification process. But in the digital signature standards, we need to provide only for the digital signature function only. So we cannot provide here any of the encryption process. That is the digital signature standards. So let us see have one example of basically happening between the sender and the receiver. The sender and the receiver goes to the first point of this function is message should be connected to the hash function. This hash function is going to be verified and this is going to send by using an signing method, and this signing method is going to combine of the whole process by using hash function and also the original message. Then after this combining, it should be goes to the verification process, means which is sent by the sender to the receiver. Basically this is the private key and this is the public key. So already we have seen in the previous of encryption for the private and decryption for the public. So same here as sender is for private and receiver should be for public. That is the sender and the receiver process. So basically we are using the private and public one. So private and public one, it should be always verification function using the whole, means by using only the hash function, it is going to be generated original message, and it should be after combining of this whole process, it is going to the message and with the securing hash. So what will happen for the sender side? So the sender side should be already seen in the previous slide of the figure. A hash code will be generated out of the message. So basically they are having the following some of the inputs. So what are those? The inputs. First one will be the very important one is hash code. If the hash code is not there, the sender side should not send the messages to the receiver. The first one is hash code. The next, by using any of the random number, that is K. For the particular signature process, we are going to see any of the K. And they are using the private key of the sender. So what we have seen here the previous slide of, that is private for the sender. So by using of the private key of the sender, it is initialized by PR of A. The next, what are the global public key? Means it mainly consists of the set of parameters. So basically we have seen here the PU of G, means it is nothing but an having the parameters of global public key. PUG is nothing but a global key. So that is the global key of parameters which is going to be communicated by the digital signature standards. And it also contains for the output signature S and R. So what is the S and R? The signature is sent to the receiver. S is nothing but a signature and R is nothing but a receiver. So basically the original message should be concatenated with the both of two. There is nothing but a signature and the receiver. The next, whatever the completion of the sender side, the next move into the receiver side. The receiver side also should be, the verification should be done, whatever the sender is going to send the message to the receiver. So there is a verification function by having of the following inputs, which has seen in the sender side. We use particular hash code and signature components of signature is sent to the receiver, and also public key. So private key is used for the sender and public key is used for the receiver. So global public key. The same of the function of PUG means nothing but a public key of global. So the after completion of this output of the verification is function is done, it should be compared with the signature component. So basically the signature component are, if the both values will match, if the send signature is valid, only of the sender with the help of its private key can generate a valid signature. Otherwise, if the values doesn't match, the signature should not be a valid, and the sender, whatever they are sending the message to the receiver with the help of the private key, the key should not be generated at any cases. That is called as an digital signature standards. So in today's session, we have discussed with the topics of digital signature and digital signature standards. In the next session, we will discuss about the Kerberos and X.509 authentication service. Thank you.